Good day, welcome to Tenacity Learning Odyssey with Mr. Blue. Today we are focusing on Grade 10 Trigonometry of two-dimensional problems. To D. Without further ado, trigonometry was developed in ancient civilizations to solve practical problems such as building construction and navigating by the stars. We will show that trigonometry can also be used to solve some other practical problems. We can use trigonometry ratios to solve problems into dimensions that involve right-angled triangles. As revision, the three trigonometry ratios can be defined for the right-angled triangles as sin theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. Tan theta is equal to opposite over adjacent. And we will use these three ratios and the theorem of Pythagoras to help us solve two-dimensional problems. From figure 1.1 we will identify the sides. Let us start with hypotenuse. The following diagram 1.2 represents the hypotenuse, the longest side of the right-angled triangle. It is clear from the diagram that the hypotenuse of a right-angled triangle is opposite to the right angle. That side will always remain the hypotenuse independent of what angle we are looking at because it is a unique side. Grab a bottle of water. Let us break this down even further. The following diagram 1.3 represents the adjacent side. It is clear from the diagram that the adjacent side of a right-angled triangle is right next to the reference angle. The following diagram 1.4 represents the opposite side all the way across the other side from the reference angle. It is clear from the diagram that the opposite side of a right-angled triangle lies exactly opposite to the reference angle. Let us do an example. Calculate the sides using our ratios. A person stands at point A, looking up at a bird sitting on the top of a building, point B. The height of the building is x meters. Point is 5.77 meters away from the foot of the building, and the angle of incline from the horizontal to the top of the building is 60 degrees. Calculate the height of the building X as shown in the diagram below. Step 1. Identify sides. On this diagram, we have hypotenuse as the longest side, adjacent, which is 5.77 meters at the bottom, and opposite, which is the height of the building labeled X. Step to check which ratio to use. Right here, the right ratio to use is tangent function, because we are given that opposite is x, which we are looking for, and we also have adjacent as 5.77 meters, and our angle of inclination is 60 degrees, which we will substitute where we see theta. Step 3. Substitute. Where we see theta we substitute with 60 degrees. Opposite we substitute with x. And adjacent with 5.77. Therefore we work it out. Step 4. We multiplying both sides with 5.77 to break the fraction. We will have 5.77 canceling, the 5.77 leaving us with x, and on the other side 5.77 multiplied and 60 degree. We work it out, the final answer will be 9.99393, which can be written as 9.99 meters rounded off to decimal places. To find other sides like hypotenuse and adjacent if the question requires you to find them, you will still use the above steps. This concludes our lesson. Thank you for watching till we meet again. Enjoy the rest of your day. Don't forget to like, share and subscribe to our channel for more content.